Have you ever opened a ViewModel file and felt overwhelmed by its sheer size? In modern Android development, ViewModels can quickly balloon from a tidy class to a sprawling mess of business logic, state management, and API calls. It's a familiar story. You start with a simple ViewModel, but as features pile up, so do the methods. Before long, you're scrolling through hundreds of lines, trying to make sense of it all. This is where many developers find themselves, facing the challenge of maintaining clarity and structure in their codebase. But what if there was a way to keep ViewModels simple, no matter how many features you add? One of the core principles in software design is the open-close principle. Software entities should be open for extension, but closed for modification. Yet, with traditional ViewModels, every new feature means modifying the class. This approach not only makes code harder to test and review, but also increases the risk of breaking existing functionality. The result is a codebase that's fragile and difficult to scale. Developers often find themselves stuck, unable to extend features without diving into the depths of a monolithic ViewModel. Clearly, a new approach is needed to break this cycle and restore order. The breakthrough came from an unexpected source: the command pattern. Instead of piling methods onto a ViewModel, what if you used objects to represent actions? Each action would encapsulate a single piece of business logic, making it self-contained, testable, and swappable. This shift in thinking transforms the way developers interact with ViewModels. Rather than modifying the ViewModel for every new feature, you simply create a new action object. The ViewModel remains untouched, and the codebase stays clean. This is the foundation of the Toad architecture pattern. Toad stands for Typed Object Action Dispatch. It's a Kotlin-first architecture pattern designed to keep ViewModels boring and maintainable. The core idea is simple. Your ViewModel has one public function, and that's it. All business logic is handled by action objects, which are dispatched through this single entry point. This approach ensures compile-time type safety, encapsulates responsibilities, and provides a clear structure for state changes. With Toad, adding a new feature means creating a new action, not modifying the ViewModel. The result is a codebase that's easy to extend and maintain. The first pillar of Toad is typed. Compile-time type safety is crucial in preventing errors and ensuring that actions only work with compatible state and events. By leveraging Kotlin's strong type system, Toad guarantees that you can't accidentally dispatch an action to the wrong ViewModel. The compiler catches mistakes before they reach your users, making development safer and more predictable. This layer of safety is a game changer for large codebases, where accidental mismatches can lead to subtle bugs and frustrating debugging sessions. Toad actions are first-class objects. This means each action is a standalone entity, not just a method buried inside a ViewModel. By treating actions as objects, you gain flexibility and clarity. Actions can be tested independently, reused across different ViewModels, and swapped out as needed. This object-oriented approach makes it easier to reason about your code, as each action has a clear responsibility and lifecycle. The result is a more modular and maintainable architecture, where business logic is neatly separated from state management. Each action in Toad encapsulates exactly one responsibility. This adherence to the single responsibility principle ensures that actions are focused and easy to understand. When you need to add a new feature, you create a new action object that handles just that feature. There's no risk of accidentally breaking unrelated functionality, and each action can be tested in isolation. This clarity makes onboarding new developers easier, as they can quickly grasp the purpose and implementation of each action without wading through a complex ViewModel. The final pillar of Toad is dispatch. All state changes are funneled through a single entry point in the ViewModel. This centralized approach simplifies the codebase and makes it easier to track how and when state changes occur. By dispatching actions rather than calling methods directly, you gain a clear audit trail of business logic. This structure is especially valuable in large projects, where understanding the flow of state and events is critical for debugging and maintenance. With Toad, your ViewModel becomes remarkably simple. It exposes just one public function: run action. All business logic is handled by action objects, which are dispatched through this function. This minimalism is intentional, making the ViewModel boring and predictable. When you need to add a new feature, you don't touch the ViewModel at all. Instead, you create a new action object. This approach keeps the ViewModel stable and reduces the risk of introducing bugs during feature development. One of the most powerful aspects of Toad is that adding new features doesn't require modifying the ViewModel. Instead, you create a new action object that encapsulates the desired functionality. Existing tests remain valid, and the risk of breaking something is virtually zero. This approach aligns perfectly with the open-close principle, allowing your codebase to grow without becoming fragile. Developers can confidently extend functionality, knowing that the core view model remains untouched and stable. In Toad, view state is your single source of truth. State is always immutable, and changes happen through the copy function. This immutability ensures that state transitions are predictable and safe. By centralizing state management, Toad makes it easier to reason about your application's behavior. Developers can trust that state changes are explicit and controlled, reducing the risk of unintended side effects. This approach is especially valuable in complex applications, where maintaining consistency is critical. View event in Toad is designed for one-time side effects, such as navigation, toasts, or analytics. These events don't live in the state, but are crucial for user interactions and feedback. By separating side effects from state, Toad keeps the codebase clean and focused. Developers can easily track and handle events, ensuring that user interactions are explicit and traceable. This separation also makes testing easier, as events can be simulated and verified independently. Instead of passing repositories and other dependencies to each action, Toad bundles them into action dependencies. This approach simplifies dependency management and ensures that actions have access to everything they need. By injecting dependencies once, you reduce boilerplate and make actions easier to test. Developers can focus on business logic, knowing that dependencies are handled in a consistent and predictable manner. This structure also facilitates integration with dependency injection libraries, making it easy to scale and maintain. View action is where the magic happens in Toad. Each action is a typed object that knows exactly what state it operates on, what events it can emit, and what dependencies it needs. This explicit structure makes actions easy to understand, test, and maintain. Developers can confidently add new features, knowing that each action is isolated and focused. The result is a codebase that's modular, scalable, and easy to review. View action embodies the principles of clarity and separation of concerns. Actions in Toad don't get direct access to the state flow. Instead, they operate within an action scope, which provides safe, well-defined operations for state changes and event handling. This controlled access prevents accidental mutations and ensures that state transitions are explicit. Developers can trust that actions only modify state in predictable ways, reducing the risk of bugs and inconsistencies. Action scope is a key part of Toad's safety and reliability, making it easier to maintain large codebases. Toad ViewModel is the orchestrator in Toad. Its only job is to dispatch actions, making it intentionally boring. This simplicity is a strength, as it reduces complexity and makes the ViewModel easy to understand and maintain. By delegating all business logic to action objects, Toad ViewModel ensures that the codebase remains stable and predictable. Developers can focus on building features without worrying about breaking the core ViewModel. This orchestrator pattern is ideal for scaling applications and maintaining code quality. Toad achieves true open-close compliance. Adding new features means adding new files, not modifying existing ones. This approach keeps the codebase stable and reduces the risk of introducing bugs. Developers can confidently extend functionality, knowing that existing tests and features remain valid. Open-close compliance is essential for scaling applications and maintaining code quality over time. Toad makes this principle practical and achievable in real-world projects. Testing actions in Toad is straightforward. Unlike traditional view models, which require complex setup and instantiation, Toad actions can be tested independently. You simply provide the necessary dependencies and scope, then verify the results. This simplicity makes it easier to write and maintain tests, ensuring that your codebase remains reliable. Developers can focus on business logic, knowing that testing is efficient and effective. Easy testing is a major advantage of the Toad pattern. Toad leverages Kotlin's generic signatures to ensure type safety. You can't accidentally use a profile action with a settings view model. The compiler catches these mistakes. This layer of safety prevents subtle bugs and makes development more predictable. Type safety is especially valuable in large projects, where accidental mismatches can lead to frustrating debugging sessions. Toad's commitment to type safety ensures that your codebase remains robust and reliable. Code reviews in Toad are streamlined and efficient. When a developer adds a new feature, reviewers only need to look at the new action file and possibly a new event type. There's no need to scroll through hundreds of lines in a monolithic view model. This clarity makes reviews faster and more effective, reducing the risk of missing important changes. Streamlined code reviews are a major productivity boost, especially for teams working on large projects. See Toad in action within a composable. Every user interaction maps to an explicit action, making the flow of logic clear and traceable. Actions are dispatched through the ViewModel's single public function, and events are handled separately. This structure makes it easy to understand and maintain the code, as each interaction is explicit and testable. Real-world usage demonstrates the practical benefits of Toad, from clarity to maintainability. Ode makes onboarding new developers faster and easier. Instead of needing to understand a massive view model, newcomers can focus on individual actions. Each action is self-contained and easy to grasp, allowing developers to contribute quickly. This modularity reduces the learning curve and makes collaboration smoother. Teams can scale efficiently, knowing that new members can get up to speed without wading through complex code. Debugging in Toad is clearer and more straightforward. When something goes wrong, you know exactly which action caused it. There's no need to hunt through a monolithic class trying to trace the source of an issue. This clarity makes debugging faster and less stressful, allowing developers to focus on solving problems rather than searching for them. Clear debugging paths are a major advantage for maintaining code quality and reliability. Factoring is safer with Toad. Moving an action to a different module is as simple as moving the file. There's no need for risky surgery on the view model, reducing the chance of introducing bugs. This modularity makes it easy to reorganize and optimize your codebase, ensuring that changes are isolated and predictable. Safer refactoring is essential for maintaining code quality as your application evolves. Ode encourages natural code ownership. Different team members can own different actions without stepping on each other's toes. This separation of concerns makes collaboration easier and reduces conflicts. Developers can focus on their areas of responsibility, knowing that their changes won't inadvertently affect unrelated features. Natural code ownership is a key benefit for scaling teams and maintaining productivity. Ode isn't perfect for every situation. If your screen has only one or two simple operations, a traditional view model may be sufficient. There's no need to over-engineer simple features. Additionally, if your team is deeply invested in another architecture, such as MVI libraries, migrating to Toad might not be worth the effort. The pattern shines in complex projects where view models are growing out of control, but it's important to choose the right tool for the job. Ode is just a pattern. There's no library to install. The core implementation is about 150 lines of Kotlin. You define interfaces for view state, view event, action dependencies, and view action, then implement action scope in Toad view model. This simplicity makes it easy to adopt Toad in new projects. Developers can copy the skeleton code, paste it into their project, and start building. Getting started is straightforward, making Toad accessible to teams of all sizes. Toad skeleton code includes interfaces for view state and view event, an abstract class for action dependencies, and an interface for view action. Action scope provides controlled access to state and events, while Toad view model orchestrates action dispatching. This structure is lightweight and easy to integrate into any Kotlin project. Developers can customize the skeleton to fit their needs, ensuring that Toad remains flexible and adaptable. After using Toad in production, several practical benefits become clear. Onboarding is faster, debugging is clearer, refactoring is safer, and code ownership is natural. These advantages make Toad ideal for scaling teams and maintaining code quality. Developers can focus on building features, knowing that the architecture supports clarity, safety, and collaboration. Practical benefits are the true measure of Toad's value in real-world projects. Some developers notice similarities between Toad and MVI, Model View Intent architectures. Both patterns emphasize unidirectional data flow and separation of concerns. However, Toad distinguishes itself by focusing on action objects and compile-time type safety. While the core principles may overlap, Toad's approach to encapsulating business logic in actions and centralizing dispatching offers unique advantages. Understanding these differences helps teams choose the right architecture for their needs. Ode integrates smoothly with dependency injection, DI libraries like HIL. Action dependencies can be provided through DI, ensuring that actions have access to the necessary resources. This integration simplifies setup and makes it easy to scale applications. Developers can leverage DI to manage dependencies efficiently, reducing boilerplate and improving maintainability. Toad's compatibility with DI libraries is a major advantage for modern Android development. Toad is well suited for Kotlin multi-platform projects. Its emphasis on type safety, modularity, and clear separation of concerns makes it easy to share code across platforms. Developers can implement actions once and use them in both Android and iOS projects. This cross-platform compatibility streamlines development and reduces duplication. Toad's architecture supports the goals of Kotlin multi-platform, making it a valuable pattern for teams targeting multiple platforms. Ode embodies clean code principles, from separation of concerns to single responsibility. By structuring business logic as action objects and centralizing state changes, Toad keeps the codebase clean and maintainable. Developers can focus on clarity and simplicity, knowing that the architecture supports best practices. Clean code is essential for scaling applications and maintaining productivity, and Toad makes it achievable in real-world projects. Toad applies solid principles throughout its architecture. Single responsibility is enforced by action objects. Open-closed is achieved by adding files instead of modifying them, and dependency injection is facilitated through action dependencies. These principles ensure that the codebase remains stable, scalable, and easy to maintain. Developers can trust that Toad supports best practices, making it a strong foundation for modern Android development. Toad's structure supports performance optimization. By isolating business logic in actions and centralizing state changes, developers can easily identify and optimize bottlenecks. The modularity of Toad makes it straightforward to profile and improve performance, ensuring that applications remain responsive and efficient. Performance optimization is essential for delivering high-quality user experiences, and Toad provides the tools to achieve it. Toad supports elegant, scalable, and type-safe state machines. By centralizing state management and using immutable view state, developers can implement complex state transitions with confidence. This structure makes it easy to reason about application behavior and ensures that state changes are explicit and predictable. Elegant state machines are essential for building robust applications, and Toad provides the foundation for achieving them. Toad's modular structure can help reduce build times. By isolating features in action objects and minimizing changes to core view models, developers can optimize build performance. This approach is especially valuable in large projects, where build times can become a bottleneck. Reducing build times improves productivity and allows teams to iterate faster, delivering features to users more efficiently. Toad offers an elegant and scalable architecture for modern Android development. Its emphasis on modularity, type safety, and separation of concerns makes it ideal for teams looking to build robust applications. Developers can confidently extend functionality, knowing that the architecture supports clarity and maintainability. Elegant, scalable architecture is the foundation for successful projects, and Toad delivers on this promise. Toad supports user-centered design by making it easy to implement and test user interactions. Actions are explicit and traceable, ensuring that user feedback is handled consistently. Developers can focus on delivering exceptional experiences, knowing that the architecture supports clarity and reliability. User-centered design is essential for building successful applications, and Toad provides the tools to achieve it. Toad encourages developers to explore the limits of code. By providing a flexible and modular architecture, teams can innovate and push boundaries without sacrificing maintainability. The pattern supports experimentation and iteration, making it easy to try new ideas and refine features. Exploring the limits of code is essential for driving innovation, and Toad provides a strong foundation for creative development. For developers interested in learning more about Toad and related architecture patterns, there are plenty of resources available. Articles on state machines, performance optimization, and architecture comparisons provide valuable insights. Exploring these resources helps teams make informed decisions and stay up to date with best practices. Recommended resources are a great way to deepen your understanding and refine your approach to modern Android development. Let's recap Toad's key concepts visually. From the ViewModel's single public function to the modular action objects, Toad's structure is clear and easy to understand. Visual representations help reinforce the pattern's principles and make it easier to communicate with team members. By reviewing Toad in action, developers can solidify their understanding and confidently implement the pattern in their projects. Toad's future potential is bright. As teams continue to adopt modular, type-safe architectures, Toad offers a practical and scalable solution. Its compatibility with modern tools and libraries ensures that it remains relevant and valuable. Developers can look forward to continued innovation and refinement, making Toad a cornerstone of modern Android development. The pattern's principles will guide teams toward clarity, safety, and maintainability for years to come. Toad emerged from frustration and iteration, but its impact is clear. By applying the command pattern to modern Android development, Toad keeps ViewModels boring and actions interesting. The pattern supports clarity, safety, and maintainability, making it ideal for scaling teams and complex projects. Sometimes the best solutions aren't revolutionary, they're just right. Give Toad a try and see how it transforms your codebase. Ready to make your ViewModels boring and your actions interesting? Start by implementing the Toad pattern in your next project. Copy the skeleton code, define your actions, and enjoy the benefits of modular, type-safe architecture. Your future self and your code reviewers will thank you. Toad is a practical, scalable solution for modern Android development, and it's ready for you to explore.